Dear children, in previous class we have discussed about reaction of metals with oxygen, water, acids and also displacement reactions. Today we are going to start another topic, that is reaction of metals and non-metals. Before going to the topic, I wanted to make you recall something we have learned in our class 9, that is electronic configuration. You know that atoms are made up of protons, neutrons and electrons. These are the subatomic particles by which atoms are made. Protons and neutrons are present in the nucleus of the atom. Electrons revolve around this nucleus in fixed circular path. So protons and neutrons are present inside the nucleus and electrons revolve around the circular path. Each circular path have specific names or denoted by K, L, M, N. The circular path around the nucleus are denoted by K, L, M, N. These circular paths have N value 1, 2, 3, 4. Each circular path or each orbit can hold a specific number of electrons that is calculated by the formula 2n square. Therefore, K shell can hold 2 into 1 square. N value for K shell is 1. Therefore, K shell can hold 2 into 1 square, that is 2 electrons. L shell 2 into N value 2. 2 square, that is 4 into 2, that is 8 electron. M shell N value 3, therefore 2 into 3 square equal to 18. So in this manner, each orbits around the nucleus can hold only a specific number of electrons. The distribution of electrons in an element according to this capacity of electron holding is called a electronic configuration. The arrangement of electrons in an element across the nucleus through various orbits is called a electronic configuration. Electronic configuration you have learned in your class 9. If you have any doubt before going to today's topic, please take your textbook and read. Let's see an example of writing electronic configuration. I am taking aluminium as the example. Atomic number of aluminium is 13. Atomic number is the representation of number of protons or number of electrons in an element. For a neutral atom, the number of protons and number of electrons will be same. So, atomic number 13, that means number of electrons is equal to 13. So, atomic number for a neutral atom will be equal to the number of electrons. Aluminium atomic number is 13 and therefore the number of electrons is also 13. Now we can write the electronic configuration K, L, M, N. These are the shells. K shell can hold a maximum of 2 electrons. Only 2 electrons K shell can hold. So first we have to write 2 electrons. L shell can hold maximum 8 electrons. Therefore 8. 8 plus 2, 10 electrons. Now from 13, 10 electrons we have distributed, remaining 3 electrons. So M shell, which can hold a maximum of 18 electrons, we are giving this remaining 3 electrons to M shell. So this 2 plus 8, 10 plus 3, 13. So the 13 electrons of aluminium are distributed to various shells. This is the way of writing electronic configuration. Now we can study about the reaction between metals and non-metals. Before going to this, we have to understand the basic difference between the electronic configuration of metals and non-metals. Here I have taken some examples of metals: sodium, magnesium, aluminium, potassium, calcium. Sodium atomic number is 11. Therefore, electronic configuration we can write as 2, 8, 1. 2, 8, 1. 8 plus 2, 10 plus 1, 11. Magnesium 2, 8, 2. Aluminium 2, 8, 3. Here potassium 19. 2, 8, 8, 1. 2, calcium 20, 2, 8, 8, 2. Electronic configuration, writing of electronic configuration you have learned in 9th standard, that's why I am moving fast. So sodium, magnesium, aluminum, potassium, calcium. These are all metals and we have arranged these metals, or we have written the electronic configuration of these metals. A metal or any element that is undergoing chemical reaction in order to attain stability. Stability means in order to attain the electronic configuration of noble gases. You know, noble gases have completely filled outer shell. Outer shell having 8 electrons or obeying octet rule are called stable. So noble gases have 8 electrons in the outermost shell and they are very stable and they are not reactive under ordinary conditions. So every element is undergoing chemical reaction in order to attain stability. Stability means gaining 8 electrons in the outermost shell. Thus 8 electrons can be attained either by losing the excess of electron or by gaining some electron. Now listen here, in the case of sodium, the outermost shell of sodium has 1 electron. If this 1 electron is removed, then its outermost shell becomes a shell with an 8 electron. That means it can attain octet rule or it can attain stability by losing 1 electron. Okay, so the sodium will always try to lose this 1 electron and attain stability. Now magnesium. Magnesium also have 2 electrons in the outermost shell. So it is easy for magnesium to lose this 2 electron and attain 8 electrons in the outermost shell so that it can attain stability. So magnesium will also try to lose this 2 electrons in the outermost shell. Aluminium having 3 electrons in the outermost shell. So it's better for aluminium to lose this 3 electrons so that it can attain stability by getting 8 electrons. Potassium also having 1 electron in the outermost shell. So potassium will also lose this electron. Similarly, calcium also loses 2 electrons. That means metals, when we write the electronic configuration of metals, we can understand that metals have the tendency to lose electron and attain stability. Metals have the tendency to lose electron and attain stability. So metals are electropositive in nature. Metals are electropositive in nature. Electropositive means tendency to lose electron. Metals have the tendency to lose electron and attain stability. So metals are electropositive in nature. Now let's see the electronic configuration of non-metals. I have taken the example of nitrogen, oxygen, fluorine, phosphorus. Nitrogen atomic number 7, that means the number of electrons is 7. So we can write K shell 2 and in L shell 5. Oxygen 8, therefore 2, 6. 6 plus 2, 8. Fluorine 9, so 2, 7. Phosphorus 15, so 2, 8, 5. So this is the electronic configuration of some non-metals. So just as I told in the case of metals, every element will try to attain stability either by losing electron or by gaining electron. In the case of nitrogen, the outermost shell is having 5 electrons. So it is very difficult to lose this 5 electron and attain stability. But if it gains 3 electron, if it gains 3 more electron, it can attain stability by getting 8 electrons. So it is better to gain 3 electrons than to lose 5 electrons. That means nitrogen will gain 3 electrons. Now oxygen also have 6 electrons in the outermost shell, so it will gain 2 electrons and attain octet. Fluorine is having outermost electron 7. It will gain 1 electron and attain stability. And phosphorus is having 5 electrons in the outermost shell, similar to nitrogen. It will also attain 3 electrons and attain stability. So in the case of non-metals, the non-metals have the tendency to gain electron and attain stability. So the tendency to gain electron is called electronegativity, or we can say that non-metals are electronegative electronegative in nature. Non-metals are electronegative in nature. Electronegative means they have the tendency to gain electron and attain stability. So metals are electropositive and non-metals are electronegative in nature. Electropositive means metals have the tendency to lose electron and non-metals have the tendency to gain electron. So metals are electropositive and non-metals are electronegative. Metals react with a non-metal. For example, we can study this reaction by taking the example of sodium chloride. Sodium, as you know, is a metal and chloride or chlorine is a non-metal. So let's study about the reaction between this metal sodium and non-metal chlorine. Sodium is having an atomic number 11 and the electronic configuration is 281. So sodium has the tendency to lose this one electron and attain stability. Therefore, what will happen? Sodium will lose one electron. When it loses electron, it becomes positive charge. Once an element loses electron, it attains positive charge plus one electron. This electron is lost. So sodium loses one electron and attains Na+. Now chlorine is having an atomic number 17, therefore electronic configuration is 287. This shows that chlorine can gain one electron and attain stability. Therefore chlorine will gain one electron and become Cl-. So here when it loses electron, sodium Na+, the electronic configuration becomes 2,8. Here when it gains electron, the electronic configuration becomes 288. Now both sodium and chlorine attain stability. Sodium attains stability by losing one electron and chlorine attains stability by gaining one electron. Or we can say that the electron lost by sodium or the electron given by sodium is accepted by chlorine. That means a transfer of electron takes place between sodium and chlorine. So this is what happens when metals and non-metals react. Metals have the tendency to lose electron and non-metals have the tendency to gain electron. So the electron lost or electron given by this metal will be accepted by the non-metal based on their necessity. So sodium and chloride react. Now we can represent this as sodium with one electron in the valence shell. This one electron, the valence shell, we are denoting like this, the number of electrons in the outermost shell. Only one electron is here. Chlorine is having 7 electrons in the outermost shell. 1, 2, 3, 4, 5, 6, 7 electrons are here. So during this reaction, sodium will give this one electron to chlorine. So what will happen? Sodium, since it gives one electron, it becomes positive charge. And chlorine, already it was having 7 electrons plus it attained one electron from the sodium. So now it becomes 8 electron. As it accepted electron, charge becomes Cl-. So Na plus and Cl- together forms this compound NaCl. So this is an ionic compound because ionic compound means a compound formed by a positive and negative charge. Positively charged ion is called a cation and negatively charged ion is called an anion. So this is an example for a ionic compound. Sodium chloride is an ionic compound. So when metals and non-metals react, they form ionic compound or electrovalent compound. Ionic compounds are electrovalent compounds. Okay children, understand? The second example is magnesium chloride. Magnesium atomic number is 12, electronic configuration 282. Here it loses 2 electrons and forms Mg2 plus ion. That means once it loses 2 electrons, it attains stability. So magnesium will lose 2 electrons. If it loses 1 electron, it will get 1 positive charge. If it loses 2 electrons, it gains 2 positive charge. So Mg2 plus 2 electron. So here it becomes, electronic configuration become 2, 8. Chlorine, atomic number is 17. Electronic configuration 2, 8. Chlorine, electronic configuration 17. Atomic number 17, electronic configuration 287. So it will accept one electron. Chlorine will accept one electron and forms Cl minus. Electronic configuration becomes 288. Here, magnesium has 2 electrons to lose, whereas chlorine can accept only 1 electron. That means this magnesium atom can donate or can transfer each 1 electron to 2 different chlorine atoms. So, one magnesium atom can combine with the 2 chlorine atoms, or one magnesium atom can give electrons to 2 different chlorine atoms, because one chlorine atom can accept only 1 electron, whereas magnesium has 2 electrons to donate. So, this magnesium can give 1 electron to one chlorine atom and another electron to another chlorine atom. So, that is how this reaction will take place. The formation of this ionic compound can be represented as magnesium with the 2 electrons, 2 valence electron, and 2 different chlorine atoms having 7 electrons. Okay, so it will donate 1 electron here and 1 electron to here. So it becomes Mg2 plus 2 chlorine atoms together we can write Cl 2, 3, 4, 5, 6, 7, 8 and electron from magnesium. Together we can write as 2. So MgCl2 is the formula of magnesium chloride. Now let's study the properties of ionic compounds. Ionic compounds are solids. They are generally hard and strong solids due to strong force of attraction between positive and negative ions. Ionic compounds have high melting and boiling points as they are strong solids. Ionic compounds are soluble in water, but they are insoluble in other organic solvents like kerosene, benzene, etc. Ionic compounds conduct electricity in molten state or in solution. The ions are free in molten state, hence they conduct electricity. With this, we came to the end of today's topic. Thank you. Read the textbook.